So I'm John Lensmeyer, Mr. John, as a lot of you know me as, and we're going to be talking a little bit about the history of algebra and complex numbers as part of our seminar today. Now, little bit of motivation and introduction. All right, so we'll do a little intro at the beginning and we'll see how things can build on each other along the way. So the basic idea is that if we're doing algebra, especially with how we think about it today, we want to solve equations. We'll see a little bit later on that these equations or things like that weren't always equations. You did a lot of these questions like maybe in middle school, early middle school, elementary school, right? A lot of these times they might be more like the equations you did, in second grade or third grade. 3 plus what number equals 7? Stuff like that there. And we can see throughout history then more complicated equations lead to the need for new number systems or new types of numbers that way as well. So let's get started with the super basics and talk a little bit about some numbers. So, right, if we talk about the counting numbers or numbers like that, right, these things mostly started with maybe tally marks or counting, right? If you're talking about, how many sticks do you have? How many people are there in your family or your group, right? This is where things kind of could be started. So you might count the number of objects, as I mentioned, right? There was a lot of things like, okay, we might want to figure out a year. When is it going to get cold again? So we make tally marks on a rock or the lunar cycle for roughly months, things like that as well. Those were some of the basics when we started these kind of counting systems there. So, right, moving forward then with that, right, we could also start talking about place value systems, right? So if we think about some of these place value systems too, right, we might start thinking about, okay, how does stuff work there? How could we kind of work with the different pieces, right? How might we represent these different numbers along the way too? So, right, although some of these earlier systems existed, there were other ones. So we'll talk a little bit more in the number theory portion of the camp, right? Sometimes you could use what's called a base 60 system, right? And this is actually something that we see a little bit today. There are 60 minutes in an hour. So breaking stuff down like that, 60 seconds in a minute. There are 360 degrees, which is 60 times 6 in a circle, right? Base 10 systems also have a history as far back as, right, 3100 BCE there in Egypt. Those systems, right, are probably based on our fingers, right? So that's where we have the number 10, 1, 0, more on 0 in a little bit, right, would represent that 10. Then 2, 0 represents 2 10s, things like that as well. And right, these ideas of numerals kind of did exist throughout time. So on this next slide, we have some picture of some Chinese numerals. Notice that a lot of this, at least at the beginning, is modifications of some tally marks. So we had 1 line for 1, 2 lines for 2, right? And then stuff gets a little bit more complicated for representing these different numbers. And these things do date back pretty far, right? These numerals are back to 1000 BCE in kind of China on tortoise shells or things like that too. So going a little bit more towards our modern notations, right? This is just kind of one way of tracking some different systems, right? Our modern number system is typically based on Arabic numerals, right? So that's where that throws up in this kind of history. And so we can start seeing some similarities, differences about these number systems and numerals through time. So we have kind of Brahmi ancient numeral systems, then some Hindu systems, Arabic, medieval, and modern. You know, some of these were pretty similar a lot of the time. Some of them changed more than others, but that kind of is one way of tracking these number systems and things like that as well. Now, before I move on to the next page, I do want to notice and point out something kind of interesting in this chart, or something that might surprise you a little bit in this chart. So does anyone have any thoughts about what's maybe interesting here, or what we might notice looking at this table of all of these different symbols here? So good, right? We have this kind of noticeable blank spot there. There isn't a 0 in that case. And so this is one of the interesting things, and this is a good preview and transition to some of the things we're going to talk about. So you might notice that this 0 was missing, right? This typically and originally the word 0 meant a lack of a quantity. So 0 was more like none. How many cows do we have? We have no cows. That's slightly different, right? It seems weird to us to think about nowadays, but that is a little different than the number 0. So the history of it as like a number or numeral is a little bit later. Some of the earlier things, right, in terms of money, right? A lot of the times tracking numbers would be how much land do you have? How much taxes do you need to take? Or things like that. So as early as 1770 BCE, this symbol kind of NIFR or NFR is sometimes seen to represent this nothingness there. So this missing 0 kind of gets us to start thinking about, okay, when we're manipulating these numbers, then how might you think of these things if there was no 0 and stuff like that. So little side track here, but I do want to give a book recommendation quickly. So there's kind of been entire books written about this. This is one of them by this author, Charles Seif, who wrote The History of 0. And it's kind of interesting too, because it's called The Biography of a Dangerous Idea. So it does a lot of this history of math and explaining kind of this history of the concept of nothing, then nothing as a number, and things like that as well. So this is something that we might mention more in later weeks or more videos, things like that. But you know, if you are interested in some of these things, there's a lot of stuff out there that's not purely, you know, a math textbook. And I do think this is a good way to inspire people to learn new ideas, learn about new things, whether it's in math or physics or computer science, things like that. So if anyone's interested, right, you have lots of different ways to get in touch with us, right? If people might be interested in, you know, getting a group together, we read through a book, discuss a chapter, or discuss it in forums or Discord or stuff each week, let us know that way as well. So we've kind of looked at the numbers 0 and drawn kind of a special spotlight on it so far, but we can start doing that more and more. So to give us a little flavor then of where we're going to go from here, let's introduce a more formal number system. So counting numbers or natural numbers. Some people fight about 0. I'm giving the talk, so we are including 0. 0 is typically included if you're talking about more abstract logic stuff or set theory stuff with numbers. So these are what's called natural numbers in our modern terms. So, right, they're used for counting objects. We have this many cows, or we have this many people in our family, this many days since the last time there was a flood or a full moon. We can do that stuff with counting numbers. And we'll talk more about equations, but you can then start thinking about these in modern terms as equations like, in terms of natural numbers, 5 or x plus 5 is 6. We can solve that equation, right? We can solve an equation like x plus m is n as long as m is less than or equal to n there. Right, and so the idea though is, and this will be the theme for the rest of this talk too, this last line is a good place to pause for a moment, but we can't solve this when m is greater than n. Now, let me put quotes around can't be solved, because we'll see, of course, that there are ways to do this, and we know modern ways of doing this. But if you have something like x plus 7 is equal to 4, over the natural numbers, right? Over those 0, 1, 2, 3, there is nothing that you can add to 7 to get 4. So our theme the rest of the day then is going to be this can happen more and more. So where do we solve this? What do we need for this equation to have solutions? What quote unquote new type of number is needed in this case? Right, so with a little bit of thought then, this in modern terms is what we call negative numbers. So here you would say -3 plus 7 is 4. And so, right, this is our idea. Okay, we might want to solve these equations, right? Now, if you're doing some accounting things, if you gave somebody too much money or too much grain or other goods you're trading, can you have a way of representing the fact that they maybe owe you money back? And that's where we start getting these negative numbers that way as well. So this is still fairly long ago, right? Like I mentioned, these could represent debts. We have then different colors representing positive or negative numbers. This is common again in accounting, right? Green is positive, red is negative. You might denote these different colors then for those positive and negative numbers there as well. And as we will see then throughout the rest of this talk, we have new types of numbers, new equations, and then there's some new equations we might want to try to solve, so we might need some new numbers. And there's this back and forth, and that's one interesting way to track progress in a sense throughout mathematical history, and that's what we'll do the rest of the day in this talk too.